This is a fundamental theorem of calculus. So what it is another way of finding the area under the curve. So normally we would make all of these little rectangles and take the limit as n goes to infinity of our Riemann sum to get the areas under the curve. Now we're going to look at it a little differently. So if g of x is continuous on AB, so we have some function here, g of x, and it's continuous on that closed interval from a to b, then, and g of x, our capital G of x, is our antiderivative, then this integral from a to b of g of x is the antiderivative. So what that means is we don't have to use the limit as n approaches infinity of all the Riemann sums. We can just take the antiderivative of our function. So if you have the integral of x squared plus 2x minus 3, we would just do our antiderivative. So what we learned before, remember if it's a constant, we down the x. Now, the difference here is these are definite integrals, and so we're not going to put plus c. What we're going to do is put a line and put 2 and 0 there. So this becomes 1/3 x cubed plus x squared minus 3x. And then if you look at our little rule here, what it means is this is our antiderivative. So this is our g of x, capital G. And what we're going to do now is plug b into it, and then plug a into it, and then subtract. So it looks like this. So we plug in 2, put that in blue. So now we've plugged in 2, and then what we're going to do now is subtract the next number that we plug in. So that would become 1/3, and then we plug in 0, and then x squared, so we plug in 0, minus 3, and then we plug in 0. And you can see that second one, it's a nice polynomial, so all of it is 0, and it's 0 all the way across. So all we have to do is really plug in these into our calculator and see what we get. So plugging in our calculator, we get 2/3. You can also use the math function in our calculator to find the integral to verify that it is correct. You still have to show work, but it's a quick way to find out the answer. So it's 2/3, take away 0 is 2/3. So instead of using the limit of our Riemann sums, all we have to do is take the antiderivative and plug in those two numbers. So there you have it, a fundamental theorem of calculus. And so the next video we'll do some more examples.